I know you're always thinking this, like, Mr. Larkin, how could we just make this class more of a challenge? Well, I have some good news for you. All that covalent bond drawing stuff we did, we're now going to take all of that and we're going to add multiple bonds. Yes. All right. Let's read about it. In certain molecules, remember, that's a small group of atoms. So you can be like, you have your little friendship molecule, you know, like the two people you always hang out with. You can be like a molecule, you know. Some atoms must share more than one pair of electron. Remember, one pair of electron, that's a covalent bond. So if you do more, you're going to have multiple bonds. If an atom shares more than one pair of electron, it forms either a double, so that'd be 2, or a triple, that's 3, bond. The types of bonds are summarized in the table below. So single, double, triple, slash, double slash, 3, bond order 1, 2, 3. F2, notice it has one pair shared in the middle. Here it has 2, here it has 3. So, I mean, it still has octet. If you look at nitrogen here, if you just look at one, it has 2, 4, 6, 8. It still has 8, but 6 of them are being shared between the two nitrogens. Let's read here. For example, the oxygen atoms in an oxygen molecule, O2, must share 2 pairs. Remember, these are all diatomic, by the way. Make sure you memorize the diatomics. Therefore, the oxygen molecule contains a double bond. So it's got a double right here. Double the trouble. But each one still has the octet. The nitrogen atoms in a nitrogen molecule must share 3 pairs. So here we have the triple. So, or 6 total electrons. The nitrogen molecule contains a triple bond, but each one still has an octet. Alright, below you will find several more Lewis structures illustrating double and triple bonds. Examine each structure carefully. Circle the electrons shared by each atom to verify that every atom has a full shell. So that's 8. Label each double and triple bond. Okay, so time to get circling. Now I gotta, there we go. Alright, so we circle that. Circle here. Circle here. And if we look inside, we got 2, 4, 6, 8. 2, 4, 6, 8 of the carbon. 2, 4, 6, 8 of the oxygen. And then let's look here for, this would be carbon. 2, 4, 6, 8. That works. And then here, this is the other carbon. 2, 4, 6, 8. Hydrogen would just be right here. It only has 2. Oh, but actually, okay, hydrogen's really small, right? So it only has the one shell. So it only having 2 is okay. And I can already tell without circling. That one has one bond, which is 2, so does that one. And then the bromine here would have 2, 4, 6, 8. It has an octet too. Alright, how about this carbon? It has a total of 4 bonds. That's 4 times 2 is 8. Same with this carbon. And the iodine has 2, 4, 6, 8. Okay, so that works. So then it says label each double and triple bonds. So here's a double, here's a double, here's a double, here's a triple. That's all of them, right? Okay, now you gotta go down to find the polyatomic ion reading. So now we're gonna look at things that are covalent and ionic at the same time. I know, like if this was your head, your mind, just like, which kind of looks like how I draw hair too. Maybe that's what hair is. Ideas exploding from your brain. That doesn't make sense. Alright, so polyatomic ions. There are some covalent compounds, so nonmetals, that can only satisfy the octet rule by gaining or losing electrons and becoming ions. These covalent compounds are called polyatomic ions. Poly means many, and atomic means ions. So they're many atoms. Therefore, these ions are made of many atoms. So typically an an ion is just one atom, but here it's actually multiple atoms bound together with the covalent bond, but still an ion. For example, one common polyatomic ion is hydroxide, OH-. Oxygen has 6 valence electrons, that's right, and hydrogen has 1, so that's 7 valence electrons, which is not an octet. If the compound was just OH, there would only be 7 valence electrons. I just said that, man. And there would be no way for oxygen and hydrogen to both get full valence shells. You could probably get hydrogen to get a valence shell, but oxygen there's no way. However, if you add another electron, there are now 8 electrons and both atoms can get a full valence shell. This extra electron adds an overall negative charge to the molecule though. So hydroxide's a polyatomic. So if we're looking here, we add that extra electron, now we can get our octet, but we have this -1 charge right here. Because if you count up all the protons, there's 8 from oxygen, 1 from hydrogen. We've got 8 electrons here, and then there's 2 electrons inside that are not drawn. So you've got 1 more negative than positive. Alright, the names, charges, and formulas for the following very common polyatomic ions should be committed to memory. Ammonium, hydroxide, nitrate, sulfate, carbonate, phosphate. You need to memorize these. Make flashcards, whatever. You will be mad at yourself if you don't remember these. When polyatomic ions are in ionic formulas, their name remains unchanged. So, no "ide." If there are multiple sets of polyatomic ions, they are enclosed with parentheses. So ammonium oxide, right? So ammonium, ammonium is a +1 right here. So there's 2 of them, so it's plus circle, and we know oxide has a -2 charge. So see how there has to be 2 of them to balance out the charge. And then copper 1 phosphate. Copper 1 is telling us the charge is +1. Subscript here says there's 3 of them. PO4, if we look up here, has a 3- charge. And so sure enough that it has to be 3 coppers to balance these out. But notice we don't need parentheses around the phosphate because there's only 1 of them. Alright, come in class ready to exercise your noggins, make your brains more intelligent, build some gray matter. Alright.